So let's talk about probabilities. Probabilities are the cornerstone of artificial intelligence. They are used to express uncertainty, and the management of uncertainty is really key to many things in AI, such as machine learning, and Bayes network inference, and filtering, and robotics, and computer vision, and so on. So we're going to start with some very basic questions, and we're going to work our way up from there. Here's a coin. The coin can have heads or tails. And my question is the following. Suppose the probability for heads is 0.5. What's the probability for it coming up tails? So the right answer is a half, or 0.5. And the reason is the coin can only come up heads or tails. We know that it has to be either one. Therefore, the total probability of both coming up is 1. So if half of the probability is assigned to heads, and the other half is assigned to tail. Let me ask my next quiz. Suppose the probability of heads is a quarter, 0.25. What's the probability of tail? And the answer is 3/4. It's a loaded coin. And the reason is, well, either one will come up with a certain probability. The total of those is 1. The quarter is claimed by heads. Therefore, 3/4 remain for tail, which is the answer over here. And here's another quiz. What's the probability that the coin comes up heads, 3 times in a row, assuming that each one of those has a probability of a half, and that these coin flips are independent? And the answer is 0.125. Each head has a probability of a half. We can multiply those probabilities because they're independent events, and that gives us 1/8, or 0.125. Now let's flip the coin 4 times, and let's call XE the result of the ith coin flip. So each XI is going to be drawn from heads or tail. What's the probability that all 4 of those flips give us the same result, no matter what it is, assuming that each one of those has an identically and equal distributed probability of coming up heads of a half? And the answer is, well, there's 2 ways that we can achieve this. One is all heads and one is all tails. You already know that 4 times heads is 1/16. And we know that 4 times tail is also 1/16. These are completely independent events. The probability of either one occurring is 1/16 plus 1/16, which is 1/8, which is 0.125. So here's another one. What's the probability that within the set of 0x1, x2, x3, and x4, these 3 or more heads? And the solution is, let's look at different sequences in which head occurs at least 3 times. Could be head, 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 in which case it comes 4 times. Could be head, 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 tail, and so on all the way to tail, head, head, head. There's 1, 2, 3, 4, 5 of those outcomes. Each of them has an 16th probability, so it's 5 times 16, which is 0.3125. So we just learned a number of things. One is about complementary probability. If an event has a certain probability p, and the complementary event has a probability 1 minus p. We also learned about independence. If 2 random variables x and y are independent, you're going to write like this. That means the probability of the joint that any 2 variables can assume is the product of the marginals. So rather than asking the question, what is the probability for any combination that these 2 coins or maybe 5 coins could have taken, we can now look at the probability of each coin individually, look at its probability, and just multiply them up. So let me ask you about dependence. Suppose we flip 2 coins. Our first coin is a fair coin, and we're going to denote the outcome by x1. So the chance of x1 coming up heads is half. But now we branch into picking a coin based on the first outcome. So if the first outcome was heads, then you pick a coin whose probability of coming up heads is going to be 0.9. The way I wrote this is by conditional probability of the second coin flip coming up heads, provided that, or given that x1, the first coin flip was heads, is 0.9. Now, the first coin flip might also come up tails, in which case I pick a very different coin. In this case, I pick a coin which with 0.8 probability will once again give me tails, conditioned on the first coin flip coming up tails. So my question for you is, what's the probability of the second coin flip coming up heads? The answer is 0.55. The way to compute this is by the theorem of total probability. Probability of x2 equals heads. There's two ways I can get to this outcome. One is via this path over here, and one is via this path over here. Let me just write both of them down. So first of all, it could be the probability of x2 equals heads, given that, and now I assume, x1 was head already. Now I have to add the complementary event. Suppose x1 came up tails, then I can ask the question, what's the probability that x2 comes up heads regardless, even though x1 was tails? Plugging in the numbers gives us the following. This one over here is 0.9 times a half. The probability of tails is 0.8. Thereby, my head probability becomes 1 minus 0.8, which is 0.2. Adding all of this together gives me 0.45 plus 0.1, which is exactly 0.55.